Okay, so I'm going to do a paired t-test, a independent sample t-test, and an analysis of variance in R. I'll be using glucose, paired, and AOV data sets. They've already been entered. So the glucose, we have values of glucose, and we have a hypothesized mean of 130. So to run the independent sample t-test, you type t.test, the name of the variable, which is glucose, and then type in mu, which is your hypothesized mean, your value, and enter. This will give you your t-value and your p-value, which is 0.06. Considering this is a medical test and it's not 0.001, we can obviously see that it's not significant. And it'll also give you your mean. Now for the paired t-test, we're going to use paired data. So we have a placebo versus for just a sugar pill versus Cymbalta for medication. So to run this test, you do t.test Cymbalta versus comma placebo comma paired equals t, enter. Helps if I could spell. Okay, so for this one, we have a t-value of negative 6.458 and a p-value of 1.518 times 10 to the negative fifth. So we can see that is highly significant. And then we have a mean of differences of negative 2.43. So we could tell that the Cymbalta is significantly different from the placebo. Now, when we want to do an ANOVA, what you would do is you generally want to save the data that you're creating. So I do AOV.test less than dash AOV length versus variety. Let me go over this real quick before I do that. The data we're working on is AOV, so we are going the length of the flower stem and the variety of the flower stem itself. So when we do AOV.test, we do the analysis of variance of the length for, with the little tilde sign, variety. So we can pull up the AOV.test, and it shows us our sum of squares and our degrees of freedom for our variety and our residuals. To actually find out what the value is, you have to do summary of AOV.test. Helps if I can spell. So the variety, we have a difference of less than 2 times 10 to the negative 16th. So there's a significant difference in the variety. In order for us to see what these differences are, you can do a 2p HSD on your test value. And this will give you the upper and lower confidence intervals so you can find out that which one is significantly different. You can see the values here that we have a negative 11 here, so that would be the highest value, a negative 7, so that would be the middle, and a negative 3, so that would be the low. So the yellow HB high is be the highest value, the Caribbean red would be the lowest value, and the high, which is the wild type, is in the middle.